Okay, students, some side splitting problems. Number one here, if a segment or a line divides two sides into the same proportion as it does here, 1/3, the same ratio on both pieces there, then the line is parallel. That's all you have to say. So the key is you have to say it divides both sides into the same ratio. Then it's parallel. All right, here it's telling me that it's parallel. Okay, then don't forget we have corresponding angles are congruent. And remember, that's called an overlapping triangle. Similar, you can also call it a dilation, centered at B. Okay, either DE is dilated to create AC, or you can say AC is dilated by a reduction to create DE. What's the length of AC? So we want this right here. Well, we need to compare that to DE. Well, those are full lengths. This is the common one that's missed. So I go 4, that's the full length of this side, to the full length of that side, the corresponding side, that's 10, not 6, equals 8 to X. So it's double there, shortcut, double there. So 20 is my answer. Okay. In the coordinate plane, quadrilateral has those vertices. Let H be the midpoint. Or let EF, GH be the midpoints of that. Prove the quadrilateral EF, GH is a parallelogram. We're not going to go ahead and do that one. All right, here we go right here. MQ is a median, so that means it goes to the midpoint of the opposite side. So you use the midpoint formula to get Q. Or midpoint, the X coordinates add together, so 2A plus 0 divided by 2, comma 2B plus 0. It was plus 0 divided by 2. So that gives me A, comma B is my answer for Q. A, comma B. All you're checking, okay, is the midpoint formula. Okay, that's all you're having to show. It's the midpoint. In triangle ABC, point D is on AB, and E is on BC, such that DE is parallel to AC. Okay, so draw a triangle. A, B, C. So point D is on AB. Point E is on BC. So that DE is parallel to AC. So again, that'd be a dilation, again, centered at B. Okay, there's similar overlapping triangles, a similarity, for example. If DB is 2, DA is 7, DE is 3. What's the length of AC? So it's like the common one we just did before. Because again, this is the most missed one because you have to use full side lengths. So again, I'm going 2 to 9. That's the full side lengths there, equals 3 to X. Okay, I can either go 2 times 1.5 is 3, and 9 times 1.5 is 13.5, or I can just cross multiply and get 13.5 that way. Okay, so the answer is 13.5. In the diagram below, they have these lengths on here. Find the perimeter of the triangle formed by connecting the midpoints. Okay, obviously, it's the midpoint, 7 and 7. Midpoint here would be 8 and 8. Midpoint here would be 5 and 5. Okay. And remembering, so these are medians. The median is always half of its base. So that's 16. This is 8. Okay. This length here would be half of the 10, so it makes that 5. This length here would be half of the 14, which makes it 7. So it's 15 and 5 is 20. Oops, 20, not 27. Okay. O is the midpoint. These are all midpoints again. Okay, so it's going to be similar to the last problem. AC is 10, so that makes these 5 and 5, which makes this 5. AT is 18, so 9, 9, and 9. CT is 22, so that makes it 11, 11, and 11. What's the perimeter of parallelogram C, D, O, G? Okay, so we got 10 plus 22 is 32. All right, in the diagram below, DE is mid-segment. All right, it's called mid-segment, which makes it half and half again. These are midpoints. Therefore, this is parallel to this, and DE is half of AC. DE is 7, AB is 10, so it makes it 5 and 5. BC is 13, which makes this 6.5 and 6.5. Find the perimeter of triangle ABC. Well, if that's 7, we know this is 14. It's always half for the base there. So now we can go ahead and find the perimeter of ABC. That's the 10 plus the 13 is 23 plus 14 is 37. Okay, ABC, just add them up. Okay. Okay, these again are midpoints. Oh, of an equilateral triangle. If it's just an equilateral triangle, then all these are congruent right here because equilateral. Okay, in the perimeter of ABC, the big one is 36, so you divide that by 3, and that makes each side 12. So since each side is 12, each of these is 6. What's the length of EF? EF, again, is half of its base. The base is 12, so this is 6. Okay, right there. All right, here we have a centroid. Because you see the medians. It's a centroid again. Okay, CF. CF, the whole thing is 24. Remember, that's 2x, and that's x, so it's a total of 3x. The whole length, so 3x equals 24, which makes x equal to 8. So that makes this, oops, that makes this 8 and this 16. What's the length of FG? 8. Okay. ACT, okay, BE is parallel, so this is side splitting theorem. Remember, if it's parallel, then that's going to be side splitting theorem. It's only a mid segment if it bisects those two sides, AC and CT. But it doesn't say that. Okay, so side splitting theorem just divides them proportionally. CB is 3, CA is 10. Since CA is 10, that makes this 7. CE is 6. What's the length of ET? So again, I can set up multiple proportions. The easiest one to go straight across. 3 over 6 equals 7 over x. I can reduce this down to 1/2. 1 times 7 is 7, so 2 times 7 is 14. I could have just cross multiplied as well and got the 14. Okay. Can always cross multiply back from 6th, 7th grade. Okay, again, we have overlapping triangles. So we have similar triangles or dilation centered at A. Okay, which statement's always true? Okay, we'll go with B and C first. Usually A is not it. So AB over AD, this over this would have to equal AC over AE. Nope, that's not it. Okay, AC over CE, that would have to equal AB over BD. That doesn't say that, so that's out. Okay, DE over BC. So these are full sides to full sides. DB is not a full side, so that doesn't work. That's out. So dang, it was A. AC over BC, this over this, equals DE over AE. Yes, full side to full side. What's like AC over BC over BC? I was gonna say that didn't make sense. There we go. That makes sense now. AC over BC equals DE over AE. Correct. Full side to full side, full side to full side. Small to large. So the answer is 1. All right. ST is parallel. So we got side splitting theorem again because these are not both the same. So it's side splitting, not mid segment. PS is 2. We have that SQ5, TR5. What's the length of QR? QR, the whole length. Okay. So I can go 2 over its whole length of 7 equals 5, the corresponding piece of 2 over its whole length, we're calling x. Cross multiply, I get 2x equals 35, x equals 17.5, or 17.5 right there. Okay, we can go back up to full page width here. Make it bigger. All right. Charge of PTRO, okay. MR is 9, MP is 2, PO is 4. What's the length of TR? Okay. So I want to call it X. Okay, I'm going to have to use that corresponding piece there and the whole length with its corresponding whole length. Okay, so if I go 4 over its whole length, 6 equals X over its whole length, 9. Now I can go ahead and reduce this down to 2/3. Oh, nice. 3 times 3 is 9. So therefore 2 times 3 is 6. Okay. And DF bisects angle BDE. So that is congruent to that. We know this is 26 corresponding angles. We can add those together. It's going to be 108. So that makes this 72 right there, which makes this 72. Okay. Well, find the measuring angle DFB. DFB. It wants that angle right there. Well, since this whole thing adds to 180, those are not supplementary because there's 3 angles, but they add to 180, 72 plus 2x equals 180. So 2x equals 108, divide by 2, and you get 54 degrees. So that piece right there is 54. So now I have a triangle sum theorem. 72 plus 54 is 126 from 180 is 54 degrees, is DFB. Okay, so putting multiple steps together there. M and O, okay, angles M and O are bisected. So that equals that, and that one equals that one. And the measuring angle, if measuring angle TMR is 28, well then that makes this 28. That's 56 plus 40 is 96 from 180 is 84, which makes both of these, half of those is 42. So now we have that. The measuring angle OTS, we're looking for this one here, OTS. Okay. So what do we have here? We have this triangle right here. We can get this angle OST because we have this is 28 down here plus the 84 plus we'll call that one Y, has to add to 180. Okay, so 100, 112 is what that adds to. Subtract that from 180. is 68. So this angle right here is 68 degrees. And then we have this triangle right here has to add 180. So the 68 plus the 42 is 110, so that makes x 70. Okay. So again, knowing your triangles and what bisect means, that they're congruent. Okay. All right, that is it.